I'm Steve Shakell, the Director of Global Supplier Management at Aero Electronics, focused on the advanced power segment.
And I'm Simon Keeton. I'm the Executive Vice President and General Manager here at onsemi.
So Simon, we've talked a lot about the vertical integration and what onsemi has to offer with that on silicon carbide. But the other side of things is the technology itself and how onsemi is differentiated there. And before you mentioned that for vertical integration, you're doing the die, but all the way to the package.
Yep.
And I think that's one area that could be really helpful from the customer's understanding is to see what onsemi is doing in terms of differentiating on the package side in addition to the silicon carbide.
Yeah, absolutely. So if we look at silicon carbide itself and just the material properties, one of the benefits is working in a higher thermal environment. So a higher temperature environment, higher switching speeds, and that's great. And you want to get the most out of the material itself. The issue is when you put it in a package, you're introducing things called parasitics as you put it into a package. And you also want to get the heat out of the package to get the maximum performance of that silicon carbide device. And so onsemi has been focused on making these packages, whether it's discrete or it's modules, to reduce those parasitic inductances and capacitances in the device itself while reducing the thermal resistivity of the device to get that heat out of the device itself. Mm-hmm. And we're doing that with things like a sintered die attach. We're doing that with a clip product versus a wire bond product, and combining these technologies together to get the maximum performance out of that silicon carbide type device. We're doing this both in discrete and module. And as an example, some of our newest devices in discrete use the top cool discrete device, again, using clip attach and also getting the heat out, as well as our F5BP. This is a module-based solution, again, using a sintered-based solution to get that heat out and get the pure thermal performance of silicon carbide to get the best advantage to the end customer.
And then the other side of that is you have the package, but then there's a lot of customers deciding with this transition of, do I use silicon IGBTs? Do I use silicon carbide? What kind of guidance are you giving customers of when do you use one, when do you use the other? Because that's a big design consideration for them.
Yeah, absolutely. And some of it, I think we start with an approach. And our approach at onsemi is we have a very large toolkit. We have silicon, we have silicon carbide. Within silicon, we have rectifiers, FETs, IGBTs. In silicon carbide, we have the diodes, we have the FETs, we have the modules, we have discrete devices. And what we like to do is understand what problem are you trying to solve at the end of the day. And that could be something that's better served by a silicon-based solution or silicon carbide. It really depends on what efficiency are you trying to get to, how are you trying to reduce the size and weight of the end application, and the application should determine the right solution. And so we don't try and force a specific solution, we try and talk to a customer about what problem are you trying to solve, and that helps us guide the conversation into, is it silicon carbide or is it silicon? The choice should be at the end customer, but ultimately the application talks the loudest and will determine what should be the best approach. Now, one thing we should really talk about, and there's a hyper focus on silicon carbide, and that's great, but there's a lot of supporting componentry around that silicon carbide. I'd be really curious to hear, how does Aero work with that to get all these complementary products around that silicon carbide device?
Yeah. That's where Aero, we have our strength in the number of suppliers and our line card breadth that we can pull in all of these different components that go around silicon carbide, or whether it be silicon as well, right? We can use these to make sure we're pulling in the right magnetic supplier, the right current sense, the right heat sinks. We're putting all this together and we're becoming experts in how these different components connect together and are efficiently designed with each other, and helping our customers make those decisions on what to use with what. And especially as they convert to silicon carbide, all of these components are changing. So that everything's having to be considered, and they're looking for Aero to provide that guidance. And that's where, as I mentioned before, we have those advanced power FAEs that can help them make these decisions on what magnetics should they be, what's the frequency, and so forth. So we're using those FAEs as the tools to help them make these difficult decisions on the components that go around silicon carbide.
Oh, that's a great value proposition for your customers, for sure.
Thank you very much, Simon, and looking forward to see what onsemi does with silicon carbide going forward.
I appreciate the conversation, Stephen. It's been great. Thank you.